Welcome everyone. Today we are gonna show you how you're gonna build a stack in Java using linked list. To build a stack, so first thing I did, I just created a class. I named it linked stack of string, but you can name your class anything you want. So it's just an object, a Java object. The first thing you need to do to build a stack or a data structure of type stack using linked list, the first element you do is you need a node. So to do node, I'm just gonna do an inner class. You can do any class you would like, but I'm just doing it here as an inner class. So to do that, so do private class. I'm gonna name the class node. And in that class, this class will have two elements. So the first element will be a payload. We're just gonna do payloads that type of strings, but you can use any payload. You can use integers, or you can use any other items you would like to use. So we are gonna call this the payload. And then we are going to have, so every node will have a payload, and then we'll have a pointer that will point to the next node attached to it. So the second thing is going to be a reference to the class node. So it's going to be node, and this we're just going to call it next because it's pointing basically to the next elements attached to it. So a stack or a data structure of type stack or a stack data structure, all you need really, it needs mainly like three functions. You need a function where you can add, when you can stack the elements on each other's. You need an element when you can remove them. I will call that function pop, and you need just one function that will check if your stack is empty or not. But to do that, you need to start with the first node. So we're just gonna do the first node. So we'll call it private node, and then we'll name it first. So this is basically the first node that everything is gonna be built on. So you have the first node. Now we're gonna do, let's create a function of type void that will allow us to add more nodes to this stack. So we can do public void, and then we'll call it push. So to add basically a node to the stack, what you really need is basically you need to pass in the payload. So you pass in the payload, and then after you pass in the payload, we can add a node with that payload into the stack. So the first thing you need to save the first element of the stack. So we're gonna call it, so this is gonna become the old first. And then we're gonna assign, first we are gonna assign a new basically node to first. So first now is basically it's a new node. And then after you do that, all you have to do now, you have to assign the payload obviously that is coming. So we are basically going to assign this payload into here, and then we're gonna link it. So you're gonna do first that next equal old first. So what's basically happening here, so you are basically keeping a pointer pointing to this. You can say, hey, remember the old first. So we're gonna remember our old first, and then we're gonna create a new the new node, and basically we're gonna assign the payload to the payload, and then we are going to move basically like make sure that our first is pointing to our old first right now. And this is basically how you are going to push a new node into your stack. The other function is, beside adding a node to your stack, you want to remove a node from your stack. We are going to call that function pop. You can call it anything you want, but we're just going to have it to return string. We just want to know which node actually get deleted. So it's going to be public string. I'm going to call it pop. Just as if we popped something, we removed something. So we're gonna store the payload. And after you store the payload, so you get the payload, how do you get it? So you get the first element. So you just, now we saved a copy of the payload because we would like to return it. So we're just gonna do return payload. So this is, we wanna know which one we actually removed. And then what do? You do first equal first.next. So what happened here is after we assign first the first.next, so basically we point this node, we basically point this node to first, and now first basically is available for the garbage collector to come and take it. And that's basically how you remove it in Java. The other element, the other function I would like to add is a function that actually I found to be very helpful, which is a function that will help you check if your stack is empty. So in order for you to check if your stack that you just formed based on linked list or from linked lists is empty, what you have to do, I'm creating a function here called is empty, and the only thing you need to do to check if your stack is empty is to check if the first node that you have is null. And if your first node is null, it's effectively, your stack effectively is empty. There's nothing in your stack. And this is all to it, really. So now we effectively just built a stack based on linked or nodes, nodes of stack. Or we built a data structure, a stack data structure from nodes. And we added a function push to add any new, we stack any new element to the stack, and pop to remove a new element, and empty to check if your stack is empty. So two things we are going to have to add. So to test this, let's add, so this is all you need. This is all you need to build a stack. But for us, we are going to have to test it. So to test it, we have to print it. In order for us to print this, we would like to add a toString function. So we just add a toString. This function doesn't really have to be here. All the reason we are adding it here is just to print our outputs basically. So we're going to do string builder or new string builder. All right. So to print stack, we have to do node. Let's say roots equal first. Or well, you have to pass us. Let's do it this way. Let's pass us the stack. Yeah. So let's pass the stack in so we can print it. So we're just gonna do stack that first, and then basically we are gonna loop over the stack. So as long as the first is not null or our root is not null now, all we have to do is form the string. So to do that, you do root dot payload. So we have the payload, and just to have it like a pretty print, we're gonna return to string. We don't really have to do this. This is just so we can see what's happening. So as long as there is more elements in the stack, we're gonna keep looking into them, and we can keep adding that payload into our stack. And then we are going to keep moving. So to keep moving through the stack, we have to do the root equal root dot next. All right, and this will allow us to return a string or stack based on, would allow us basically to return the stack payloads as a string. So let's test it. So to test it, so we have to add a main. So public static. So let's do void. Main. So this is because this is basically just a function to print in Java. So to test it, let's instantiate a new object to do that. All right, so we instantiate a new object now. So let's basically add some elements to it. So we are going to push. Let's call the first element first. Let's add another element. Let's call the second element second. Let's call the third element the third. So basically we added 3 elements to the stack. We add the first, second, third, and now let's print it. So to print, to stack, we're just basically going to do a system println, and then we're going to pass our handy toString function that we just wrote. All right, so let's run it. So you see that we added, so you see that the stack that we are printing right here, it prints third, first, third, second, first. It's just the nature of the stack, because the stack, you know, is you stack them. So the first one that come in, it's going to be the bottom, and the last one you add in is going to show up the first, just because it's the last one in, first one out. So let's now we tested our push function. Let's test our pop function. So let's try to pop some element, and then let's print it again. So I'm just gonna be lazy and copy this. I did push, I need to do pop. All right, so you can see here what happening is we are adding 3 elements, first one, second one, third one, and then you print it. You can see this is the first one. This is the first print statements. We added the 3 elements, then we popped it. And then you can see after we print in, we only have 2 right now, first, second. So you can see that the third one was the last added, and the first one to be out. And then what we can do something similar, but then let's be lazy, just copy paste. And here, they just add another element. So push, simply just call this the 4th. So let us add the 4th element. So if you print it, all right, so you can see that this is the first print. So we add 3 elements, we print it, printed 3 elements, we popped 1 element, then we print it. You can see that it removed the third because it was the last one added. Then we added the 4th here, and we print it. So basically, like, we added it at the top, so first, second, third. And this is all what to the stack data structure. So if you want to ever build a stack data structure in Java, here is how you do it. I'm just going to remove this code. You don't really need this. But this is basically your data structure as a stack. Thank you. Remember to subscribe and like this video if you find it useful. Thank you.